A 1,500 kilogram car moving at 8 meters per second rear ends a 500 kilogram car that is initially at rest. Both objects stick together on impact and move with a speed of 6 meters per second. We're going to start by writing our given kind of in our margin. Mass 1 is 1,500 kilograms, initial velocity or V naught at 8 meters per second. Mass 2 at 500 kilograms, initial velocity or V naught of 0 meters per second. Final velocity for each is 6 meters per second. Because they're connected, they're moving at the same rate. We know that impulse is force times time. It is also a change in momentum, which can be calculated as mass times final velocity minus initial velocity. It's asking us about the 1,500 kilogram car, so we're going to take 1,500 kilograms times 6 minus 8. 6 minus 8 is -2. -2 times 1,500 will get us a -3,000 Newton seconds. So the impulse or change in momentum, same thing, is -3,000 Newton seconds. Number 2 asks us to describe the impulse that the 500 kilogram car experienced from the wreck. We should remember that impulse is force times time, so they share the same force but in opposite directions. If the previous problem had -3,000, this one will be a +3,000. But just in case we want to calculate it, we can remember impulse is change in momentum, mass times the change in velocity, final minus initial. The mass of the smaller car is 500 times its change in velocity, 6 minus 0, final minus initial. 6 minus 0 is 6, times 500 is a +3,000 Newton seconds. This brings us to number 3, the final question of the warm-up. How does the magnitude of the force that each car experienced in the wreck compare? Justify your answer in a paragraph-length response. Well, they are the same as far as the magnitude. They are absolutely the same. How can we justify that? Newton's third law states that each or any object that is interacting with another object, or each car that is in the accident, in the collision, they will experience a force equal in magnitude, but opposite in direction. We can also reason that the time of contact is the same for each. So if their force is equal in magnitude, time is equal in magnitude, so will the impulse be, but it'll be opposite in direction. So Newton's third law states that each car or object will experience a force equal in magnitude, but opposite in direction.